Okay, ladies and gentlemen, welcome to the General Maths Solutions. Hopefully this is beneficial to you, and I'll try to, zip through it, but not too fast. If you have questions, stop me and ask. So starting with our first question, one of the things I always get the kids to do with their exam, identify what type of question I'm doing, so you know what you're doing. So in that, even if it takes them 30 seconds or a couple minutes, flick through the exam. Oh, question one's a normal distribution. Question two is this. So they know what type of question they're going to be answering. It makes it easier for them to know where to, if they have to go to their formula sheet. It also hopefully means they don't make the mistakes between the loans and the investment question when they come to it in the test, because that is probably an area which still is being got wrong. It was an area issue with maths apps. It's still an issue with general mathematics. So let's get into the first question. Clearly, first, part A, normal distribution question for this one. Most feedback from the SACE board was that most students were able to do this successfully. And, first question, mean in the middle number here, take away our 2.4, get the answers, make sure you've got your decimals, and move on to the next question. Marks for the standard deviation calculations and a mark for the correct mean. Question 2, although I've done all the setting out, they only really need the 0.2940 to get their mark. It's 1 mark. It's done on the calculator. Even though it asks for percentage, it's 1 mark. They're not going to be penalised for not putting it as percentage. What you do in your test, totally different, but in the exam, it's a 1 mark question. Question part B, it wants an integer value, so you need to put an integer. It has to be a whole number. That's where the students lose their mark. They just give up that easy mark. They're leaving it as a decimal. They're not worried about saying batteries or putting units in. Without the integer, as I said, 1 mark. Whoops. The part C, the students struggled with the graphs. A lot of students got the tail wrong, or they went with B. D was clearly the correct answer. They realised that with this that mistake was being made because a lot of students went and did the inverse normal calculation correctly for 90%. So they're actually struggling to understand the connection between the graph and what it actually means for finding that inverse. So if the students can get practice at those, that will probably help them in the long run. D1. D1, this question here. So we've been given a slightly different way of doing the question. So we've got, the mean life and the standard deviation of the two brands. Clearly, the mean life of brand Y was lower than the mean life of brand B, so Z. So you're looking for those two, where are they going to fit, which sort of gives you either B or D, and then you're looking at your standard deviation. A smaller standard deviation means it's squished together, so the peak of that graph is going to be higher. So therefore, B is the correct answer. Lots of students didn't quite get it. They went for D, thinking that higher mean means it's going to have a higher frequency. But the question where most of them got stuck was part 2 of this question, where they're asked to support the statement where brand Z are more dependable. You're looking for to get the 2 marks. There were 2 bits of information. They had to identify that brand Z had a higher mean, but the second mark, where a lot of students missed out, was that because brand Z has a higher standard deviation, it's going to be stretched more to the right, and they both start at the same spot. So it's really important that just saying that brand Z has a larger standard deviation won't give them the mark. They have to justify it with why does it fit with the graph, because it could just be it's got a higher standard deviation but it's got a lower mean, so it's not going to actually be true. So it is about looking at all of the question when answering that one.
Excuse me.
Yep.
So I do have a question. If they get that multiple choice one wrong in the last one.
Up here, yep.
Yep. And that was sort of influenced their part choice too. So when you're marking it, do you sort of take that into account
so
and give them mark for two even if they got the first two wrong?
So it is the follow through marks, like that standard across all the maths. Other things I didn't mention at the start was, you know, if they make something wrong, if they cross it out, we don't look at it. So don't get them to cross it out. Now, it's really hard because a lot of questions are only worth 1 mark. If they leave 2 answers there, they lose a mark because they don't know the correct answer. It's only worth 1 mark, they get nothing. But, you know, only cross it out if they're 100% certain that it is wrong. We don't, as I said, don't mark, which is the same across all the maths. It came in a couple years ago. It sort of caused a bit of chaos for all of us. But it is one of those things that, you know, cross it out if it's wrong. If you're not sure and it's worth more than 1 mark, maybe leave both answers there, but you're going to be penalised because you don't have the knowledge. But yeah, with that question, if the students had gone D and then their justification reflected what that graph was, well, they're going to get their marks for that justification. So yes. The other thing is, if they don't mark it at all, and then they try to have a guess, because they haven't done any answers, and I'll talk about it later on, they won't necessarily get the mark for having a guess. And I'll explain that when that comes up later on. But yeah, if you've got any questions, please call them out. That will be great. Question 2 is a superannuation question. So really good, identify what it is. You know, our students are pretty good at using their calculators to do the TVMs calculations. The big error that they make is with the putting the negative signs for PV, FV payments when needed. Now, there is no need for them to include the negatives in the exam. There's even no need for them to write down that information, N, I, PV, etc. But what it does is it helps the marker see where their error is. If they've only got an answer and it's wrong, it's 0. If the markers can see, oh, they've done this, but they've switched 2 values around, it's considered 1 error, they lose 1 mark. So it's pretty much 1 error, 1 mark deduction, 2 errors, 0 marks, because they're mainly out of 2 marks. If it's only out of 1 mark and there's an error, well, clearly you're going to lose all of the marks. The downside was the other thing that come back from SACE board, a number of students are still struggling to do simple interest calculations. You know, they've been doing it since year 9 and they still can't get it. So it is worthwhile emphasising this is a simple interest calculation. Or this one was just a percentage calculation, but they're still struggling with those sort of calculations. How you get to the 19,000, you would need to make sure this was a decimal value because they've told you that it's 1960. If you just write 1960 there and have the calculation, you're not going to get the mark. And the other one, you know, it says quarterly, so it needs to be a quarterly calculation. Students are doing their own calculations, they're finding it annually or monthly. And that's usually because they're just copying what's on their formula sheet. So it's really important, get them to highlight quarterly. Oh, that means it's divided by 4. As I said, part B, this is a standard TVM calculation. Most common mistakes with this one is that students will put in how much income the person has as the present value. So it is about giving them exposure to the questions set up like this so they're used to seeing them. You'll notice that, we know that the PY and CY are always going to be the same for these exam questions. So they can, if they know one, the other one's going to be the same. Part C, there's a lot of possible answers there. If the student did that, does the scattergun approach, if any of those answers are wrong, they lose marks. So even if they've got the first two right and then the next two are wrong, they'll lose the 2 marks. So we're not encouraging students to put down multiple answers. I've just put down all the ones I could think of at the time of what it is. Because it says we want the balance to be higher, we need to say that it's an increase or a decrease in fees charged. So you can't just say, oh, the interest rate changes, because that's not telling me whether it went up or down. It has to be an increase in the rate. There's sort of been a move away from those generic type answers to either contextual answers or like this, how is it going to be better, how is it going to be worse? Part D was, an interest rate calculation. So students struggle with putting in their negative signs, and they usually end up with no answer at all, or they end up with a negative value or something that's not meaningful, and they just leave it blank or they just ignore the negative. So it's really important they get their negative signs there. I've written here in my notes, PV and FV, common mistake, they have them as the same sign. Again, it's a little bit of reading the question. So in part E, she's got a balance of 90,000. She wants 90,000 in there at the end. So a lot of students made either PV or FV equal to 0 and got the wrong calculation. Other than that, it's again the same type of calculation. And hopefully they've got the idea of those. And doesn't really matter which one's negative, which one's positive, so long as they're different. For the last part of this, for part E, if they just work out N, no matter, and don't convert it to years, they don't get the second mark. So even though there's a TVM calculation, just getting the number of weeks won't give you the 2 marks. You need to, because the question asks for it to be in years. Regardless of what value they get there for N, if they convert it to years, they still get the mark for converting to years, because they've shown they understand what to go from weeks to years. And I've divided by 12, not 52 in the solutions. Didn't pick that up. Sorry. Oops. A few people picked up when they were doing it that for part E1, which is why I've got a solution down the bottom, that it is just a simple interest calculation for 1 year, or equivalent to 1 year, or per week. So that's why you could do it as a simple interest. But I would be, the students are probably going to choose to do the other calculation. That's what they're used to seeing. Question 3, clearly a Hungarian algorithm question. Overall, this question was done quite well. It's sort of indicating our students have got a good understanding of Hungarian algorithms. Do you want to just, over in the back corner is the air conditioning units. I don't reckon they're on anymore. Sort of, I'll pick them up. Part A, it's a case of the students just reading the table and choosing by or for. It says which one might put the highest bid on item 2, look down the table, it's buy a 4. And I think 100% of students answered that question and probably got it right. Question part B, we're told that they're wanting to maximise, so to get our 2 marks here, we need to state the rule. So, we're subtracting 23 from every value from 23 because 23 is the highest value, because the question is a maximising problem. And to make life easier, they haven't asked the students to do it because some of them can't do basic calculations. So they're trying to make it less and less opportunity for students to make mistakes for these type of things, because it just adds to the mark process. This part 2 of that question, so B2, and I've done every step of it. We would expect to see the students do that. So it is using the Hungarian algorithm process. So, we're minimising each row by taking the smallest value from each one. Whether the students show that or not, it's not important so long as they can show the reduction for the rows. We're doing the columns. So we end up with our new reduced one, and we've got our 3 lines. Now it happened that this one, the only way you can put the 3 lines in is this format. We then look the next mark, so you got 1 mark for the top 2. For here, after the lines, is when you go to do this next one, is the subtraction of the smallest value from each of them, and adding that value also onto where the 2 lines cross over. As I say to the students, the 2 lines cross over, they make a plus sign, so you remember to plus. So that's just a little way of doing it. And then, it worked out beautifully. We ended up with 4 lines. And as I said, most students up to here that have attempted the question have got probably 100% of their marks. Where students gave up that easy mark, again, you want to know why our students are not getting there, is in this part here. It says, fill in the spaces, interpret your solutions from part B. So work out who gets what, add them up. The charity will raise. Now, when we add up the numbers, we get 68, but they were if we go back to our original question, the bids are in hundreds of dollars. So therefore, the charity is actually raising $6,800. So they needed to put $6,800. So it was the context that was important there.
With the lines, when we put the lines in, you've used a highlighter. Should we encourage them to use a highlighter?
I did a highlighter so you could see the numbers. They can do whatever they like.
Only because when they put lines over, some kids obscure the numbers. So
Yep.
Is that a marking issue? Or
I haven't noticed it, but if they've got a lead pencil, put it on with a lead pencil.
Yeah.
Or if they've got a highlighter, use a highlighter. It really doesn't matter. Having a highlighter is useful in general maths.
Yeah.
Because you've also got, brain's gone dead, the networks questions, the precedent networks question. And a highlighter in that can also be useful because it's a way of identifying things. So it is, one of those things. If you want to, depending on how many kids, buy a few highlighters and have them there for the exam. Then they were really nice for this Hungarian algorithm question. They basically did all the work for the students. They went and made a change, gave them a new thing, told them they put dummy columns in there, reduced the thing, and then said, okay, complete the statements below. In all possible solutions, buyer 2 will get item 1. We can identify that by looking at the table above here, or what it's been reduced to. If we look down item 1 column, buyer 2 is the only one who's got the zeros. So therefore, they have to be the person buying item 1. Doesn't matter what solution I do, that will always happen. What other outcome is possible in all possible solutions? If we look at buyer 4, they end up with the dummy link all the time, or the dummy columns all the time. So they don't end up with an item. So just by looking at the table, the students would hopefully be able to find those answers, which was something I worked out as I was going through and doing the solutions for today and having another look at them. If they swapped the answer, there wasn't any penalty, even though it did say, buyer will get an item. If they said, well, change it to will not get an item, they weren't penalised for that. They don't have to use the same language. They can say misses out or whatever language they want to use, so long as it's clear that buyer 4 didn't get an item. For part 3 of this question, it's a little bit misleading. It's 1 mark. So really the mark was given for finding the total amount raised with this new scenario. So they have to go back to the initial table up the top of that page, add the 3 values together and get the 4,950. Although it says difference in total amount raised, nobody was actually looking for the 1850 because it's only 1 mark. But that's where you need to look at how much is the mark worth. Good students are going to put in 1850. Most of the students are probably not going to do it, but it's 1 mark. They've done the mathematics. They've done what they've been asked to do. So they're going to be given that mark there. Part of the reason for moving it to this was students were rewriting out Hungarian algorithms and just spending time writing down stuff they didn't need to already do because it was already done for them. So it's really important that they don't waste time repeating calculations that are already done. Question 4 is either a linear or exponential regression. So although from the SACE board, I went on there to look at the feedback. They've said, oh, it's a linear regression. Just initially, we don't know, but hey, it's starting to look, it's definitely one of those regression equations. Come down here a bit further and we're told a linear model has been fitted to the data and we're given what the model is, we're given the R² value, and then we're asked to do a calculation or make a prediction. Hopefully you're encouraging your students, even if they don't know, have a guess. They've got a 1 in 3 chance of guessing right. We're not going to know that they didn't know it if they've got it right. But they may be able to eliminate some things. So with this question, it was, where are we? First response is not supported by the R² value. It's saying it's moderate. R² is indicating it's probably strong. The y-intercept is clearly not going to be at -4 because the y-intercept's up here somewhere around 100 and something. So the only answer they could use is the third answer. So even without necessarily knowing their stuff, if they could look through it and think it out a bit. But it is, the graph's going down. As one value increases, the other value's decreasing. Oops, did I miss a question? I think I did. There. Then the question asks us to interpret the slope, and this is where they're finding that the students don't understand what they're doing. So when it came to interpreting the slope, you can almost give them a generic type response in that talking about dependent and independent variables. Because it's going down, and we know it's going down because it's -4.68, we can say for each 1 degree increase in temperature, the relative humidity falls by 4.68%. Now, how you word it is going to be okay, but you're looking for that increase in the dependent variable resulted in whatever change to the increase in the independent variable results in the change to that dependent variable, whether it's up or down, depending on what the scenario is. So the more the kids get used to the language and understanding what the graphs mean, the easier it is for them to be able to answer these questions. And I actually get the kids to write that on their formula sheet so that they know, you know, independent variables on the x-axis, the dependent variables on the y-axis, what's going on. Completely different lot of data, new place, 24-hour period, and they've just asked us to work out R squared. So, you know, it's a case, put the numbers in our calculator, do the scatter plot, find the R squared value. Because I've drawn my scatter plot, now this question was done really poorly. The students would choose the wrong answer. A lot of times they were looking at well, we're not sure. We're guessing they've looked at the values and taken a guess from that. They've drawn the graph to find R squared. Go back to their scatter plot, put the line of best fit in, and look which dot doesn't look like it fits. And if they don't know which dot it is, they can use the trace function on their calculator to find that point. So just, you know, use that, find the point, record it. If it's asked to write it as a point, make sure that they write it as a point. This time they were just asked to do a tick. Part E is worth 1 mark. So they've asked, remove the point and then calculate a new regression equation. If they've chosen the wrong point, they will get follow-through answers there. That's part of the reason they said, here, you've got 1 of 3 points to choose, because it increases the marking time. The time to get stuff marked is reduced, but means there's less possible answers we're looking for. Although I've written the answer in terms of our 2 variables, H for humidity and T for temperature, if they've used X and Y, because it's 1 mark, it doesn't matter. The only time they need to use the variables given is if it says in context. Okay, so, but good habit, get them always to write it in context, because then it just becomes nature. Oh, I'm talking about, and we always know the questions will always have our independent variable on top and our dependent variable on the bottom, so the students can work that out, or in the first column and second column. Part F was a little bit strange because both of our values were extrapolated values. They're not within our data set. We've got a relative humidity of 100%, and you can either use the graphics calculator, you've come up with the equation, you've copied it in and use that and just read it from the graph, or it's probably just as easy to use equation mode or do it in Solver and do it that way, because the kids have written down the equation. So teach them to use that equation solver mode, because it's really useful for doing these. It's a quick way to find the answer. It also means that when we come to exponential equations and we're finding the independent variable, we can use the same thing. We don't have to worry about drawing graphs, etc. Because sometimes our view windows go all out and the students can't find an answer. Same thing, again, use the graphics calculator or that, and those answers are going to be accepted. If the student has done different rounding for here, the answers, you know, it's going to impact what answer I get here. Their follow through, they're accepted. You know, they're not being told. If they're given an equation, you would expect to have a little bit more accuracy. And there's no, you know, hard and fast rules. There is nothing on the front of the exam that now says, you know, they have to go to 3 significant figures, but they should be encouraged to do that, or at least go to, you know, say, hey, go to a couple decimal places. Try to keep some accuracy. Part G was a little bit strange because, as I said, both results were extrapolation. And they're asked which one is less reliable of the 2 unreliable results. So it's about them understanding Well, if I'm sort of close to the graph, it's going to be a little bit more reliable than if I'm further away. So, you know, the F2 would be less reliable because F1 is closer to the data given. Or the other thing we noticed, and I forgot to mention it, was with the second calculation, we ended up with negative 10 point something relative humidity. Now, we can't get negative relative humidity, so therefore the answer is not a sensible answer. So sometimes it can be, is it a sensible answer that I'm getting? If not, well, clearly it's not going to be reliable, or it's going to be less reliable. The other one is that was a mistake students were going, they just ignored we assume they just ignored or they forgot to include it. So they get a negative. Hey, on anything other than our finance calculations, you need to include it. Yes, sorry. Were you waving? No, okay. Question 5, another finance question. This time we notice it's an investment. The first one is effective rates, or analysing the interest rate. Because you're analysing it, you're only wanting N to be 26. You don't want to times it by the 4 years because that would be over the whole length of the investment. I is 2.7, standard effective rate calculation. For option C, we haven't seen a flat rate one for a few years. Yes, you can do it, and I think I've got it down further, the long calculation method, but we can do that as an effective rate as well. It's 1/4. The reason it's over 4 because it's a 4 years flat rate investment. If it was a 10 years, it would be 1/10. The interest rate is whatever interest rate we've given, so 2.15, and we end up with an effective rate of 2.08. Which then leads us to part 2 of part A, which means B is our best option because it has the highest effective rate. Students still, you know, emphasise to them, if it's an investment, I want the highest rate. Still a lot of students were choosing the lowest rate and going, oh, this is the best because it's got the lowest rate. So they clearly didn't realise or didn't understand an investment, I want more return on my money, not less. Part B, the key point here is the $5,000 that he's starting with, so we need to put that in as a payment, a present value, negative 5,000, payment, negative 45. So long as those two signs are the same, you'll end up with the right answer. Doesn't matter which way around it needs to be. You're told that the answer is 15,700, so again, they need to put the decimal value. Otherwise, they're not. If they just put it down, we don't know whether they could actually, just putting in the information won't give them their mark, their 2 marks. We don't know whether they could actually do the calculation or they're just writing down information. Part 2, use technology. The amortization function is on the calculator, so get the students to use it. It gets rid of all of those errors where students forget to include the 5,000 because that was the most common mistake they did, and they ended up with, you know, earning interest of about 6,000 and something dollars. So by using the amortization function, they can easily get that answer correct. They're not having to do it. And yeah, the more they use it, the better they'll get at it. You know, and the sooner they're introduced to it. So if you've got year 11s, get them using it in year 11. Get them used to the idea of use the technology. That's why they paid for it. Part 3 of this question was another one of those, you know, these are the questions that they're setting up for those top end students to get marks in. But hey, it's not a difficult question. They're saying he doubled his weekly deposit but didn't double the interest earned. Why would the interest earned be doubled? it's not going to be, because there's already the $5,000 at the start. So just doubling the payments doesn't double the answer that he's going to get. And that's because the $5,000 in there at the start. Part C, the really important parts here was the students identifying that it's to be no more than 15,700. So it's a inflation question. So you could either use the formula and then use the solver mode. We don't want it to be more than that, so we'd have to round down. And the rounding was what was really important, because they had to understand the context, what the question was asking. You know, it's about catching it's not catching those kids out, but making sure that they understand what they're doing, not just going through the motions of answering questions. And there's always, you only need 2 or 3 of these 1-mark questions, and that drops the student from an A+ back into the A band. There's the option C, doing it the long way, which, it's in the textbook, but there's they don't need to do it. They can do it using this conversion function on the graphics calculator. I apologise to those people who use TIs. I don't know how to use a TI. I know you can do it, but I don't know how to do it. Question 6, critical path analysis. See, I've got my notes here. Students are still having difficulties with the dummy links. So really important that they, work on those dummy links. They don't get exposed to a lot of them, so maybe go through, get past exam questions where the dummy links are, and make them into your questions you're giving the kids in class, so they get used to practicing them. As you can see, I've used the highlighter here again. That was more because that makes it easy to stand out. Part A, it's asked for the tasks that are immediately preceding task L. So they were only meant to answer C, E and F. If they put down A and B, it's an incorrect information, therefore they lost the mark. So it's about making sure they answer the question that's being asked, not what they're used to seeing. On the network, carry out the backward scan, and this is where students gave up their mark because they messed it up with the dummy link. The other part where they lost was they were going up here. They didn't realise the 5 and they'd end up with 17 there. But yeah, it's usually somewhere in there that they're messing them up. So lots of practice. State the critical path. They can either write it down here. If they're going to highlight it, they need to make sure it's really clear that it's highlighted and what the path is. If there are 2 paths, use 2 different highlighters to identify it if you're going to do it on the network, or write it down. Because sometimes there'll be the 2 paths and they don't always see, it's not always clear what the path is. Calculating the slack time, because of the way I do my backward scan, I work out what all the possible values are for the latest starting times. So therefore I'd have, earliest starting times 12, latest starting times 17. So 17 take 12 gives me my 5 days. The other way that I saw being calculated was the second option. Start with the minimum completion time, take away the task length for task J, and then take away the earliest starting time for that task, which will also give you the 5 days. So it's 2 different ways of doing it. And then that rate, don't necessarily teach the students both ways, but if they're really struggling with one way, it may give them an alternative path that they can use to do it. Question D, unfortunately a lot of students actually lost marks on this question. We're told they start on the 1st of December. We're told it's 25 days. Both the 25th or 26th of December were accepted. Some people said, well, they started on the 1st and counted that as day one. Other people said they started on the first was day 0 and 25 days after that gives you the 26th. We're splitting hairs, we're not going to argue with them. But the most important part was they had to include the month. So if they just put down the 25th or 26th, they got 0 marks. They had to include the month because the month is important. The 25th could be the 25th of January, who knows? Which means it was more than 25 days to do the task. It also then flows into the second part of the question, which says, in the context of the problem stated, one assumption made when giving your answer. So this is where those generic statements can't be used. They have to put it back into the context of the question. So, you know, it's still, work is done every day, including weekends and Christmas Day. Or there were no delays due to bad weather. So that's almost a generic statement. So it is that putting it into context of the question. But if there was no context, they didn't get their marks. So it's really important context is put in there. Might do this for this one. Is that still okay? Hopefully okay to see. The reason we're making it a little bit smaller is because all of them refer to this network here. The changes, they made some changes. They took out some paths and they had this new path that G is now prerequisite for L. So they're putting in the dummy link. To get their mark for their dummy link, it has to be in the right place. So clearly going from G, the end of G to the start of L. It also has, you know, should be dotted, but they weren't being penalised for that. It needs to have the arrow to indicate which direction it's going. Okay, so just having a dotted line there is not a dummy link because it's not telling me a direction. We then carry out our forward scan. Clearly, if we haven't got it in there or made a mistake, follow through would occur. And it is just a case of adding the numbers up, putting in the largest value in. So this question, they've done both a forward and a backward scan, which leads to part G. From that, we can see that our completion time didn't change, and the number of critical paths has now increased. We've got 2 critical paths. Because we could go across the bottom, A, B, G, K, M, but we've also now got the dummy link path as well. We can now include L. If the student didn't do parts E and F, they can't actually just have a guess for part G. If they did part F incorrectly, the answer they give in part G has to reflect their incorrect answer in F. So if they went, oh, yeah, this will be doesn't change, I'm going to tick that, but their answer doesn't indicate that in part F, they don't get the mark because it has to be correct for what they've done. So sometimes it is a case that, you know, they got the right answer, but their mathematics behind it was all incorrect. So that answer is not correct for the mathematics they've done. So, you know, that's follow through working almost in reverse. Question 7. Again, investment question. It's a loans question, which included both a sinking fund and an offset account calculation. Here's our simple interest question, and students still get that wrong. They go and try to do it as a TVM. Little hint, they're only given a small space, so that should give them the hint that it is an interest only, and it says interest only, which is simple interest. I tend to, so they don't get their interest mixed up, because I then see kids doing calculations of interest using the simple interest formula. I say simple interest and I write SI for simple interest, rather than using just I like they would have done in year 9. Part B, students did this reasonably well. It's an example of an annuity, so PV is going to start at 0. I've got no money in the sinking fund at the start, and I've got to raise that up to 450,000, and we're finding our payment. Again, needs to be decimals because they've given us the answer. Part C, just watch out. One was in months, one was in fortnights, that we use the correct values when we're multiplying it through to get our total. If the students want to combine it as one sum, that's fine. I've just split it into 2, so you've got it there to see what's going on. Part DI, it's the give me mark. Every student should be able to do it. It's a simple subtraction calculation. The second part, we're used to things being done for a long period of time. So we're taking the number we've found in part I as our present value, that's our loan amount, and we've got it, that lower amount in there for 6 months, so we're finding the future value. They then reuse that value, so clearly if we're making mistakes, adds to some difficulties. But we're withdrawing the money we had in the offset account, so the PV needs to increase by the 15,000, and we find a new N, which happens to still be 65.9 months. If they've rounded it to 66, that's fine. It's not going to matter. And then the last part is calculating the total amount paid. So it is a case of how many months, and gee, it's 96, which is same as 8 years. But we end up paying less with the loan compared to the offset, compared to the sinking fund and interest only loan. So when we get to part E, the students are just choosing which is the best option. If they haven't done calculations and they've just gone, oh yeah, I think it's going to be this, again, they can't earn the money, earn the marks. They've got to do the calculations prior to that to get the marks. Just having a guess and putting something down isn't going to give them the marks. Just saying option 2 with no explanation also won't give them any marks. Question 8's a nice little critical path analysis question. With this one, it was just a case of filling in the table. So we can see D, task D, using the dummy link again, means that we want tasks A and E. I wrote them E and A. Task F only wanted A, and H has F and D. So most students got 3 out of 3. The odd student missed the dummy link part and got 2 out of 3 for that question. Completing the diagram with tasks C and G, so it's just read from the table. For that, to get their 2 marks, they need to have it drawn starting and finishing in the right places, have the arrows on it, and also be labelled. So if they're missing any of those bits, or if it's not drawn in the right place, they're not going to get their marks. But if they're missing the arrows or the labels, they lost a mark. So it's one of those where they could potentially just lose marks, but have most of it right. Don't label it and don't put the arrows on. Have them in the right place and get 0 out of 2. Part C, it was a case of just working out which one, be careful, it's got false, which one of the statements sort of didn't work, which was tasks A and B cannot both lie on the critical path. If I have 2 critical paths, they could both lie on, so therefore that was the incorrect response there.
Can I ask you a question?
Yep.
Couldn't that be the first one as well? If there's, because you just said the possibility.
because it has to be false, either task A or E, have to be on the critical, what's it say? Yeah, it must, either task A or E have to be on the critical path. So that is actually a true statement. It doesn't have to be both of them, but either one of those has to be on there. Because I either go from here, I either have to go A and around, or I could go B, E, D, H, J. So one of those two has to be on the critical path.
But
Because
they could both be on the critical path if there's two.
But if there's two critical paths, they could both be on. It's always hard because it's that double negative question, and
Yeah, so I think that's acceptable for the same reasons the second one's acceptable. But
because it's saying that. I hate English. I know this. That wasn't an option that was, it was.
wrong if they selected it.
So if they selected the first one, it was marked wrong.
I think, sorry,
Yeah.
I think the word or means it's either that one
Or-
that one.
Yeah.
It's not false,
Yeah.
I think. I could be wrong, but that's what I think.
So it's saying either A or E would be on the critical path, which means that statement is true, which means it's not false. If that when I went through to work out which
It would
one,
be false if there were two critical paths.
yeah, but the statement on its own is true, so therefore it's not false. The only one that could possibly be false is the second one, that A and B cannot both lie on the critical path, which could only occur if there were two critical paths.
I'm still confused.
Yeah,
I'll accept it, thank you.
Yeah, I'm sorry. Yeah,
Would you prefer
It-
the wording say
it-
A or E or both?
yeah,
But in maths, or it's got to be A or both.
yeah. It's one of those. Yeah, you hope that the feedback goes that they go, that the language was confusing rather than the actual what they were trying to do. I look at this paper and I go, there's talk about, more and more exams are going electronically. This is sort of feeling like they're trying, how could we make it look a bit electronically? Well, let's hope it's a long way away. All right. Question 9. You sort of go, "Phew, got to 9. Again, it's a regression type question. We've got, we're talking about days after the first case, number of new cases recorded. We've got a scatter plot drawn for us. We've got some information, and then they've gone and said, which of these linear models fits the data best? Given the fact that I am probably have to do some calculations with that data anyway, I would say to the students, put it into the calculator, draw the scatter plot, and that will give you the fact that the line of best fit actually lies below there, because our equation, and if gives us which they haven't given us at any point, when you look at the B value, it's negative. So we know that it's not going to go through 0, 0. The other thing to look at is with the line of best fit for a linear model, this one here, most of the dots that are above the line, there's only this one dot above and this one that's sort of sitting on. So most of these dots are well below, whereas they should be about evenly spread around that line. So that's why D is the best option. Clearly A and C aren't, because they're not linear models. Part B asks the students to only use the residual plot above. Therefore, they can't go and start talking about the shape of the graph or the R-squared values, because that's not part of the residual plot. So this is where the students have to understand, what does the residual plot tell me? Well, we know the linear model won't fit because there is a clear pattern, or it appears like a pattern. So that's their first point. Most students identified that one. The one where the students didn't identify was the fact that our residual values are relatively large compared to what our values are. So if you look at this, we're going from 60 to minus 80, which is why the scale is there. So that the students need to identify, it's not just, is there a pattern, but also what is the value of those residual, or the magnitude of those residual values? Are they large, therefore we wouldn't accept it? And I think, you know, Hazy has a couple questions right at the start of this where they have those, why wouldn't this one be acceptable? And it's because the residual values are large compared to that. It's one of those good, I really like that as a question. It's a good way to test students' knowledge of residual plots. Part C, determine an exponential model for the data. A and B are constants, and the variables are appropriate for the context. So they've told use the context, so therefore we need C equals 4. Now I've gone to 3 decimal places. If the students went to 1 decimal place, it's not ideal, but it'd be okay. But if they only went to whole numbers, it wouldn't be, because I'm going to have 1 to the power of D, which is just 1, which isn't going to give me an exponential model. They probably wouldn't think of that, but that's why, you know, the more rounding you do with these, the more extreme the values get as we go, because it is an exponential model. The students really struggle still with interpreting these values. You know, what is A in the context of this question? Well, initially there is approximately 4 cases. You could say there were 4 cases at the start. They just have to indicate that it's 4 and it's at the start of the trial or the start of the recording. Yep.
Just going back to question C, part 1.
Yep.
And I apologise that I haven't done the exponential.
Yep.
How would they get 1 mark on that?
Oh, they get 1 mark if they've got the right values.
Yep.
And they have used X and Y.
Okay, fair enough.
Yeah. So the first mark is for doing the equation correctly, and the second mark is for using the right letters.
Thank you.
Yep.
So what do you encourage the students to do? What rounding do you encourage them to do?
I sort of say, look at the numbers. If I've got a single digit number, I'll sort of say, write down 4 digits. So if I've got a 2-digit number, you might go to 1 decimal.
So one of the earlier questions, the one with the linear regression, there was 5 digits. There was like 5 significant digits, because it was a 3-digit number with 2 decimals after it.
Yeah, it's about coming up with, you look at the, so I say to the kids, 1 to 2 decimal places for most of them, but if it's only a single digit, make sure you've got at least 4 digits, probably no more than 5. So they're sort of working that, because it's a level of accuracy. You know, if I round too quickly, I'm not going to be accurate. If I put down too many digits, it makes it horrible to work with.
But then if they're using
if they're using the graphics calculator and they're doing it from the graph,
yeah.
it's fine. Because they can just write. They still want to write down 2 or 3 digits. You know, write down, and then they're using the graph. That's fine. But you still want to have some indicate that I'm using, you know, multiple decimal places, but you're not writing down, you know, a whole string of numbers. And, you know, if you're using the whole value, you're probably going to 5, you know, 5 digits will, 4 to 5 digits will cover that, oh, this student's been very accurate.
So it's all right for the
Yep.
kids to put 5.
Yep. There's no rule saying that they can only use 3. So unless there's something that says to 1 decimal place, they can use whatever. But if they're writing down, you know, a big string of numbers, well, that's not being efficient with their time. But they haven't been penalised for having excessive. They're more likely to be penalised for being too small. As I was saying, interpreting our values, the A in the context, we need that. The B value, the students, because B is greater than 1, it's indicating that there's an increase. So they can either say increased by 12.5% per day in the context of our, the number of new cases is increasing by 12.5% per day. Or they could say it's increasing by, I need to multiply it by 1.25 times. Like the number of new cases is increasing by 1.25 times each day. Personally, I'd encourage, use the percentages. Don't go timesing. But students, if they put down just increases by 1.25 or 125% or anything else, they're not getting any marks because they don't understand the context of the question. It's only a 1 mark question. So again, there's not a lot of room for you either got it right or you got it wrong. And getting it right is understanding that it's a multiplying effect, I'm increasing by that amount. And part D is where our numbers start to blow out. If I use the formula that I used, we got 4,738. If the students used a different, 4.0 times 1.1 to the power of 6, they're going to get a different value. That answer is going to be accepted because it's followed through with their calculation. From the graphics calculator, you're getting 4,850. It's a 1 mark question. So if they're put down 0.5, they're not going to be penalised because they've done the calculation correctly. Again, encourage them. I can't have half a case. So they should be using whole integers. Get them into the habit. So it's about that habit forming. Likewise, with part 2, because I can have part of a day, you could leave it as a decimal there. But, if you're using the equation or if they've been given an equation, use the solver function on the calculator. It's really quick and I don't have to worry about, is my view window going to destroy me? Or from the calculator, and our numbers were relatively close for that one. Part 3 was a little bit of a new type question. We haven't seen this sort before. And they're just saying, how long does it take for the number of new cases to record to be doubled? Now, the key is we're basing it on the model that we've come up with. So when I double the new cases, I need to, if I'm going from the start, I'm going from 4 to 8. Or I could use the 10,000 that I had here and double that and get 20,000. And I'm going to get somewhere between around about 6 days for both of them. So it doesn't, they just have to show, start at one value, double it, using the equation, how many days difference was it? They could have used, they could have even used the 4,850 and doubled that to work it out, and they'd still get the same thing. Explanation. So this is one of those, most students got 1 mark for this question. They quite often struggle to get the second one because, again, it's that question sort of splitting those high kids to those A+ kids and the A kids. They needed to identify that an exponential model is continually increased, or this model continually increases. So therefore, now the problem with the model is eventually everyone gets infected, so the rate of infection is going to slow down as less new cases occur. The other one is, it was a topical question. So students, were talking about other strategies to reduce caseloads, such as vaccinations, that, everyone, what was another one? That the government intervenes with lockdowns and things like that. Anything that was a viable reason for why the number of cases slowed down was an acceptable answer. So it was about identifying that exponentials keep growing up and up and up, but so that intervention the model won't keep working forever because it is going to slow down for some reason that was a valid reason. So that's the exam.